Tonight we're talking about digital voice. And by digital voice, I mean digital voice where the digital part goes over the air. Just to hose down an argument I've been having with someone for a while. I do mention the other modes later on, but this is about digital voice over radio. So basically I'm going to be talking about these modes for the moment: D-Star, DMR, YSF, P25, M17, and remember the star on P7 and M17 when we get there, because there are reasons for that, and free DV. I'll be looking at a whole pile of concepts around the digital side of the system, and I'll be looking at the individual modes themselves. I'll be telling you what Quark repeaters we have up, which is not going to take long, and we'll look at, in the end, we'll have a quick look at hotspots. This is not going to make you experts on digital modes tonight. This is just literally to let you hit a whole pile of high points, give you some buzzwords. When you see something on the net, you won't instantly go, what WTF? You go, I heard about that. That's to do with digital audio. I need to go look at this, and I've got some pointers to go do that. That is the purpose of tonight. If you have questions, unless they're absolutely burning in your brain, please keep them to the end, just to try and keep the flow going. I probably have too many slides. Such is life. So starting off with concepts. So the core concept is we have a mic, we take your audio, it goes to an audio amp, gets converted to digital. All of us know about this. Then it gets encoded in some form using a codec. Then the mode's protocol gets wrapped around that, which is the information about how it controls what's being sent, who receives it and such. Finally, it's fed to a modulator, and then off to all those messy RF bits. Fortunately, those messy RF bits are increasingly coming in one chip these days, so it's not really a problem. The reason I split the codec and the protocol is they are two separate things, and we'll have a look at that in a minute. In fact, we'll look at that now. So a codec is an encoder. It's like an MP3 or AAC or similar. It takes your digital, your unencoded, digitized audio and converts it into a more compact or compressed version of itself. Typically in the voice space, we're talking about taking a 3 to 8 kilohertz signal, audio signal, and compressing that down into about a 1.6 kilohertz bandwidth for transmission across the air. The idea, like MP3s, could get you a 12:1 compression on your music. Your audio codecs do something very similar. They compress it right down by anywhere from 3 to 5 times, and allow it, the digital part of the system later on doesn't have to send as many bits to get the intelligible audio. One of the reasons, there are a number of reasons for doing this, one of which is efficiency, and spectral efficiency has become a big deal. Particularly in the US, which tends to drive a lot of this, but in the EU as well, where most of the specs we use are coming from, they're moving to 6.25 kilohertz channel spacing. So your signals have to fit inside 6.25 kilohertz. Different manufacturers have done this in different ways, and we'll look at that in the next slide actually. But the codec is an integral part of that, because you have to get the content you want to send across that smaller bandwidth. Now, the different modes use different codecs. There are some that use the same codec, which is convenient when we get to hotspots. I'll tell you about that. The earliest amateur one was D-Star, and it uses the AMBI codec. AMBI and AMBI Plus 2 are proprietary codecs created by a company called DVSI in the States. They are, well, the AMBI codec is no longer patent encumbered, but the AMBI 2 one is. But the company will not tell you that they're patent encumbered, and if you ask them, they will definitely tell you that you need to buy a license for any of these from them. So there's a lot of fear, uncertainty, and doubt in the amateur community about things like writing your own AMBI decoder and such, which plenty of people have done. They've not been sued. Again, the AMBI codec is no longer in the, it's in the public domain now. The patent has expired, and it has expired worldwide, as far as I'm aware. The AMBI 2 one, however, they changed a few bits, made it a bit better, and whack another 75 years on top. It's awesome. Codec 2 is a free open source codec. It was created by a guy in VK5, along with a few people around Australia. I'll go more into this a bit later on in the M17 side. M17 and the older FreeDV versions use codec 2. It actually has varying bit rates anywhere from 512 bits up to 3.6 kilobits. The most common these days for that is 1.6 kilobits, which gives you a reasonably good audio, similar in quality to AMBI actually. Reasonably good quality audio for not a lot of bandwidth. And the last one is RAID. RAID is a really interesting beast. It's a fairly recent invention, again by the same guy that did codec 2. VK5 DGR, I think he's called something. It's later on in the slides. RAID actually uses machine learning to go through the encryption, the compression process, and build the code book that it uses to map everything to. It actually has been very specifically processed for machine learning. What the people are calling AI these days, there's no AI. And it's been optimized for HF. So it deals with HF very well. RAID is very interesting. And if you're actually playing on HF, I'd very much recommend you give FreeDV and RAID a try. It's surprisingly good. Doesn't want to talk to me. So I'm not going to spend too long on this because it really is more about the numbers than anything else. So D-Star uses a 6.25 GMSK. Now GMSK is Gaussian minimum shift keying, which is basically just minimum shift keying, but the digital data is sent through a Gaussian filter. So it basically makes it not quite as spiky, and it doesn't create large rises and falls, which have real troubles being sent through it doesn't create edges, which have troubles being sent through a radio. All the rest basically use 4-channel FSK at the lowest level, but with different variations on it. DMR uses TDMA, which is time domain multiple access, which means that it uses 2 signals in one after the other sequentially. So it's actually a 12.5 kilohertz channel, but it gets the equivalent of a 6.25 kilohertz channel by having 2 channels encoded within the one signal. YSF is straight C4FM with an AMBI plus codec. We'll get to YSF later. P25 is the same, although P25 now has a TDMA mode as well, phase 2. And in many cases, P25 and DMR are very similar because they're actually built sort of aiming towards the same specification in many cases, more the trunking commercial side. Again, we'll sort of mention that a bit later on. M17 is 12.5 kilohertz 4 FSK. It's probably the simplest of the lot. And FreeDV, the FreeDV RAID sits in a 1.5 kilohertz channel using OFDM. So it's all of them comfortably run inside the new FRAS requirement for 12.5 kilohertz in our new channel organizations, although most of our stuff is still 25 kilohertz. D-Star is even better than that, although DMR and P25 meet the spec by having 2 channels in that. Now, a slight side run here. Most of these modes can be talked together, can be connected together by a thing called reflectors. Does anyone know what a reflector is? We know the VK1 reflect, don't we? Right? Well, VK1 reflect is a mailing list where we all can join in and chat together. A reflector in the digital world is exactly the same thing. It's like a conference or a room. They will also be called conferences or rooms. Under IRLP, they might be called conferences. Under Echolink, they're all called conferences or rooms. In All-Star, they'd be a node, because each node is its own conference. In D-Star and DMR, you actually talk about DCS and D+ reflectors and XLX reflectors. Now, these basically are places you connect to, and I'll explain how you do that later on, where once you've connected to them, other people on their places, either on their hotspots or their nodes, can connect to the same reflector, and you can all talk to each other. For instance, last night I was on D-Star with Jim, 2JHG, and Murray, 1MDP, and we were connected to the Skegness reflector, which is in the Midlands, UK. Also connected to the Skegness reflector was Jim, ON4NT, ON5NT, from Belgium. And he was coming in via his hotspot into the Skegness reflector. And so we're also talking to George, G4HG or something, who was in Skegness. And so we're all chatting together, even though we're all using different nodes, different hotspots, we're all able to chat together because we're all using the same reflector. Now, you'll see things like XLX, FCS, DCS. Now, the DCS and D+ were the original style of reflectors. They were built for D-Star only and remain D-Star only. Most of those are gone. There are a lot still listed, but what's actually listed is the DCS access to an XLX reflector. FCS reflectors are solely for YSF, and we'll talk, when I do a little spiel about YSX later on, we'll talk about FCX. But XLX reflectors are multi-protocol. There's one here in Queanbeyan, XLX 301, which our D-Star repeater is attached to most of the time. And lots of people connect into that, and they can actually talk amongst themselves, and they talk out our D-Star repeater. There wasn't really a good place to put this slot, which is why it's a bit of an aside today. But just remember that these are these reflectors, and that's how these modes talk, or that's how you can take a one repeater and talk to hundreds of repeaters at once around the world. Right, so let's move a bit on. Let's move on to the modes themselves. Let's start with D-Star. It was actually funded back in the early 80s, late 80s, by the Japanese government, and by a grant which was given to the JARL, the Japanese Amateur Radio League. And the development was then outsourced by the JARL to develop a digital ham radio protocol. ICOM became a partner in that, and they are the primary hardware supplier. Although there is actually hardware available from Kenwood, and used to be some boards for Yaesu, some Yaesu gear as well. I know some people in town have some plug-in boards that let you do D-Star on the back of your Yaesu, but they're fiddly and horrible. Flex Radio apparently supports it as well. So in D-Star, now, we've gone beyond the protocols now, and what we're talking about is how you actually use it. And that's where the major differences and the concepts come behind it. In D-Star, you have 4 call sign fields, right? You have a my call, a repeater 1, repeater 2, and a your call. And the idea behind that, and each of those fields are 8 characters long. So if your call sign is larger than 8 characters, you're out of luck. M17 has the same problem, although its field is 9 characters. And DMR doesn't use call signs at all. Well, none of the others use call signs. So the idea behind it is your radio, you put in your call. Which is your call? In my case, it's VK1KCM. The repeater 1, you put in the call sign of the repeater you want to transmit through. That might be a call sign of your hotspot. It might be a call sign of the local D-Star repeater, and there'll be examples later on. Repeater 2 is a call sign of the gateway you want to go to. In this case, it's almost always another call sign on your hotspot or another call sign on the repeater itself, because the gateway function and the radio function are separated in D-Star. And finally, you've got your destination call. Now, do I have it here? Yes, here we are. So I've color-coded this actually, just so you can work it out. So your call sign field, my call. So again, your call sign is your call sign. Some of you have more than one. Repeater 1 in our case would be VK1 RBMC. Now there are three call signs typically defined. A for 23 centimeters, B for a UHF, C for a VHF. I don't know if there's a 220 or a 6 meters. I haven't seen them. Again, defined to some extent by ICOM, and they only sell those three. Our VHF radio is VK1 RBMC. See the space there? 1, 2, 3, 4, 5, 6, 7, 8. Has to be 8 characters. All right, which becomes important in the next slide. So in our case, if you're talking to the repeater, it would be VK1 RBMC is what you would always put in for our repeater. The gateway. Now, there can be multiple gateways. The gateways can have different call signs but still be attached. For instance, if you've got a fairly heavy site that has multiple nodes, stuff is backhauled, it's all a bit odd, you can have different gateway call signs. In our case though, we've got nothing that complex. Our gateway is literally a tiny little orange pie running G4KLX's IRC DWB gateway software, and its call sign is VK1 RBMG. So when you're communicating, you're talking through your radio, talks to the repeater then passes on your data to the gateway, and it knows to do that because it knows to talk to VK1 RBMG. The gateway then looks at the destination you call, or it looks at what's currently connected. The two can be separate as to where the information goes. Now, the default UR call in D-Star is CQ, CQ, CQ. And that's basically just talk to anyone. Even if you're not calling CQ, if you're just having a conversation, that's what you use, except in one case. You can put somebody else's call sign in there. So for instance, I'm talking to Paul, the K2CJ, and he's up in the Central Coast or something, and I happen to know that he's on the radio. I can put my call, RBMC, RBMG, VK2CJ, and the system will try and find him, because the system does the IRC part of IRC DWB Gateway is an IRC back end that logs where everybody is. So as soon as you key up on a D-Star repeater running IRC DWB Gateway, it'll know where you are and it'll be able to route calls to you. The other way of doing this is on the next slide, so we'll talk about that in a minute. Now, there are two types of systems in D-Star. There's the IRC DWB Gateway type, which is probably the more common now, particularly outside of North America. And there's the old system they call US Trust, which is actually using the ICOM G2 and G3 software. Now, the ICOM software, you have to actually go to the website of your repeater and register. And it then knows that's your calls, that's where you are, right? And it will route stuff to you at that repeater in that call sign. And if your call sign appears on the network, it'll let it through. If you don't appear in the US Trust system, your call sign just gets blocked. You just get dropped whenever it gets to the US Trust system. Now, there are plugins for the US Trust system which talks to the IRC database. So those of us that are using the IRC database can talk to a US Trust system, but you need to be registered. Now, if you go to the website, the CRARC website, and in the D-Star spot, it explains where to go to get your registration, because there's a site you can register. We don't have a registration here anymore. We don't bother with that. But you can register remotely, and that means you'll be able to dial a US Trust system, and it'll work. But the vast majority of systems don't, and unless you're having troubles, you may not need to worry about this too much. So the last thing that the UCall is used for is link control. It is one of the ways of controlling the repeater. So in the UR field, you can do one of three things. You can link the gateway, not the repeater, but the gateway, to another gateway or reflector. You can unlink it if it's already linked, Or you can find out if it's currently linked by just doing an information. It'll talk back to you and tell you what's going on. And the way you do that is by you give the call sign of the repeater you want to link to, or the node XLX301. You'll note that's 6 characters. You'll note that's 6 characters. Now B means B. In this case, remember on repeater 1, the B meant the frequency. So B was a UHF. So the Central Close Diameter Radio Club has a D-star repeater with multiple ports, and you can connect to the UHF port by putting a B in that location there. And then the last one is an L that must be in the 8th location. And you key up for about 2 seconds, dekey and wait. And the system will come back and say, connecting to VK2 RAG B. And then at the end, it might say connected to the Central Close Diameter Radio Club UHF, or it might say something else. Everybody's different. Then if you've got, now, sorry, I missed a step. These are all programmed into your radio. So with most D-Star radios, you can either plug them in and save them as a memory. That's the older style. The newer styles actually have ways of easily doing it on the front panel. I have an old radio. I haven't used one of the newer ones, so I don't know how the newer ones work. But the underlying infrastructure is exactly the same. So in this case, you can put an I. Actually, you can even put VK2 RAGBI, and ignore the rest and just do the I. And it'll tell you what's currently linked to. The gateway is linked to. And again with the U, multiple spaces, 7 spaces and then a U, unlinks it or disconnects the gateway from the system. Now, it should automatically disconnect after about 30 minutes of no RF. And then it should automatically reconnect back to XLX301 in the case of our local D-Star repeater. That's how I've set it up. The other way of doing it is you can use DTMF tones. So you can literally put in your UR call field, you put CQ, 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 RBM-C, RBM-G, CQ, CQ, CQ. And then you just hold the key down and use your DMF code. So if you want to talk to, say, XLX301, channel Charlie, most reflectors have different channels. Didn't mention transcoding, did I? Okay. So if you wanted to connect to XLX301 Charlie, you go A30103, and that would get you onto 301 Charlie. And you can do the same. You want to talk to, we were talking to XLX678 last night, 678 Delta, so that would be star 67804. And then it'll tell you. So you don't need to program into your radio the connection, you can do it. This works for hotspots as well as our repeater on ISACs. It only works for MMDVM based equipment. So if you're using a US trust system, and there are some in Australia, there's some in Melbourne, there's one in Sydney, one in Brisbane. If you're using one of those and this won't work as far as I'm aware, you've got to use the plug in the radio stuff. But this works on our MMDVM based stuff, which is quite useful because otherwise it's a bitch programming a radio. One thing I forgot to mention with reflectors is the multi-protocol bit. Because remember when I said that it was a good thing that DMR, YSF, P25 all use the same codec? The repeaters don't interpret the audio, they just pass it through, right? D-Star uses AMBI, the rest use AMBI 2+. A lot of XLX reflectors, for instance, Rob's one, XLX301, has multiple channels that are transcoded such that if the audio comes in DMR, in AMBI 2+, it'll actually send it off board to a USB device that contains the DVSI chip on it. It'll transcode it into AMBI, bring it back into the system, and then feed that to anybody connected via a D-Star system, and vice versa. So it means your DMR, your YSF, your P25 systems can all talk to D-Star and vice versa. If you're on DMR and you want to talk to YSF, it literally is just a case of changing the wrapping around the outside. And there's actually systems in hotspots called DMR to YSF and YSF to DMR that lets you connect to DMR systems from a YSF radio and YSF systems from a DMR radio. There are some caveats on that, which I'll get to in the YSF portion. DMR stands for Digital Mobile Radio. They got real creative with that. It's actually a European standard done by the ETSI. It's a public standard. In fact, D-Star is a public standard. DMR is a public standard. P25 is a public standard. YSF is a public standard, but YSX is not, which is, we'll get to that again. And again, I'll come back to this 2 time slots in the 12.5 kilohertz bandwidth because they're called TS1 and TS2, and that actually ends up being important because when you talk in DMR, well, sorry, go back one. The time slot 1 and time slot 2 are actually independent. And on our repeater, you can have 2 separate stations, one talking on time slot 1, one talking on time slot 2 on different talk groups, and they won't interfere with each other. The system will handle it. A bit like trunking, but on the same frequency. They actually use a timing signal from the repeater, and the handheld radios synchronize their transmission to either be in time slot 1, which is the first 30 milliseconds frame, or they're in time slot 2, which is the second 30 milliseconds frame inside the DMR, because there's 2 DMR slots in one time frame. So you can actually have 2 people using the repeater at the same time as long as they're on different time slots. And talk groups are numeric. There are 65,000 and some change talk group numbers. And so you need a DMR ID number. Now, a DMR number is just a number between, I think it's 8 digits now, 7 digits, 8 digits now. And it'll start, because you're all in Australia, you might have a different one, but they're all in Australia, they'll all be starting with 505, because Australia is the international prefix, DMR prefix, 505. You'll sort of see that in a number of places in YSF2, I think. These are all managed by a website called radioid.net, which allocates DMR numbers and YSF numbers and all sorts of stuff. There's all sorts of things that it manages at the moment. So when you want to get DMR, when you first get your DMR radio, you have to go to the DMR Radio ID website. So who's got themselves a DMR ID? So you've all done it. It's pretty easy. Did you do it while you were here or while you were in here? So you'll have a 505. Yeah. So the DMR ID is mapped to your individual call sign. You can have multiple DMR IDs, but they really frown on it. You've got to have a really good reason for it. The reason being the DMR numbers are actually a finite resource. And so if you go and have lots of DMR numbers, they're going to run out of numbers eventually. The only reason you need a second DMR number is if you're going to be transmitting at the same time on 2 different radios. There's no issues having the same DMR number on multiple radios as long as only one of them is transmitting at a given time. They can all be receiving. That's not a problem, as long as only one of them is transmitting. So if you've got a DMR radio on the car and a DMR radio on the house, there's no issues with them having the same ID, unless you've got a second ham at home who's going to pick up the DMR radio and call you, in which case you need 2 IDs. So then you just get it in their call sign, not your own, not theirs. So DMR comes in 3 trunks, in 3 tiers, sorry. The first is an unlicensed tier we don't have in Australia. It's the PMR 446 band. In Europe, in 446.35 to 447, they have an unlicensed, bit like a UHF-CB band here, except it's only half a watt max. And so the tier 1 was designed for 6.25 kilohertz or 12.5 kilohertz channels in that band for 0.5 watts. It was literally designed to be the ones sold for at Tandy or the EU equivalent. Tier 2 is the conventional PMR type radios, talking through a repeater, talking simplex like we normally do, and that's the one we use. And tier 3 is trunked. In a trunked radio, you don't have a specific frequency allocated to you. What that does is each tower you talk to has a control frequency, and it then may have anywhere from 1 to a dozen ancillary channels allocated to it. And when you key up, your radio keys up on the call channel, the control channel, and the control channel and the repeater then says, Paul's calling. I'll keep picking on you because you're right there. Paul's calling. He wants to talk to talk group 12,000. I'll allocate him the third channel, tell his radio, and I'll stand up the third channel and away it'll go. So your radio will then transparently, while you literally as you hold the button down, it does the ping, gets the call back, changes frequency to the secondary, the transmit channel you've been allocated, and then continues the conversation transparently. So it means you can have hundreds of radios out there, and you can allocate 5 talk channels. And as long as there's only 5 simultaneous conversations, 5 different talk groups being activated, or services, then no congestion, no one cares. Most PMR sites only have sort of 6 channels maybe allocated. A lot of them are being converted to phase 2 PMR. This is different to that. A lot of those are being converted to phase 2, which is 2 channels at a single frequency, but it just treats them as if it was extra frequencies. So that's what trunking is. There is some people in the ham community playing with trunking, DMR trunking. I don't know of anybody doing it for real yet, and there are certainly no amateur radio oriented handhelds or radios that are trunking capable yet. Those that are playing with it are using commercial gear. I didn't mention roaming here, and I'm not going to. You guys can look up roaming later. So in a DMR system, all communication is via a talk group. A talk group is like a channel, but the channel is shared. Now, how far that channel is shared depends on how the network is configured. Channel 9, for instance, talk group 9, TG9 and time slot 1 is not the same as TG9 and time slot 2, sort of. In an MMDVM and DMR gateway, the back-end software, which I'll get to in hotspots, you can actually map these around. So you can change talk group numbers. You can move channels from slot 1 to slot 2 and back again. Most hotspots, any simplex hotspot, only uses one time slot 2. Right? They don't use time slot 1 at all. And everything is automatically folded into time slot 2. Even if your radio is programmed up to say this is on time slot 1, but you're talking to a hotspot, it'll talk on time slot 2. Because when it talks to the handheld, when it talks to the hotspot knows. But our repeater on Isaac's Ridge is a full duplex. It can handle both time slots. So time slot 1 is time slot 1 and time slot 2 is time slot 2. Of course, if you've only got the one time slot in your hotspots, in a simplex hotspot, then of course you only have one person using it at a time. Just remember that. Not that that's usually an issue. So repeaters can operate locally, and to operate locally, you talk on talk group 9. So you'll all have talk group 9, time slot 1 programmed in. If you just want to have a chat locally and you don't want the whole world to hear it, or all of Australia to hear it, you talk on that. There are DMR simplex. You talk on talk group 99, TS2, I think, 439 something or other, and you can actually talk directly handheld to handheld as a simplex. There is a way of doing it. I don't know many people that bother with that. It's worthwhile having a play. I've only got one DMR radio, so I'm not talking to myself. Now, your repeater is connected to a DMR master. The DMR master you connect to determines which network you're connected to. The master determines what talk groups are available. It also determines the policy of the network, determines whether a talk group is static or dynamic. Now, a static talk group is one that always appears. So if someone transmits on a static talk group, then that talk group will automatically, for every repeater that's allocated that's in that network, it'll go to every single one of them. The only static talk group in VKDMR is 505, which is on time slot 2. There are only 2 talk groups on time slot 2 in VKDMR. One's the Parrot, 9990, and the other is 505. So 505 is typically always available to you. You can sit there and monitor 505, and if someone chats, you'll hear it. If you want to talk on one of the other ones, the dynamic ones, so for instance, channels, talk groups 3801 through 3809 are general chat channels. You want to have a chat to someone, you call them on 505, you then migrate to, say, 3802. But 3802 is dynamic, which means you have to key it up first to make it active and to tell the master that this repeater wants to listen to it. What that means is that only the repeaters that have specifically someone who's keyed up on that channel, only them get to listen to that particular conversation. So say, Paul's talking to Graham and they're on, Paul's up in the Central Coast still living the high life, and Graham's here in Canberra wondering about why the hell he's here in the cold. If you guys wanted to chat, you'd both talk to you'd call on 505. 505 would key up about 75 repeaters around the country and 200 odd hotspots. You'd go, let's stop annoying people, let's go to 3802. You'd both go to 3802. You would both then ka-chunk the repeater. You know those ka-chunking skills we've all honed over the years? They've finally come in useful. And once you've ka-chunked the repeater then knows someone's here on 3802, talk group, time slot 1. It tells the master then routes any audio between them. If somebody else fires up on 3801, right, they'll be added into your conversation. Sometimes you get jumped on. Because you can turn to 3801 and listen, and there's nothing there. So when you go to 3801, you don't just listen, you could chunk it and then listen to see if someone else is already talking. And if someone is, and you go, sorry guys, we'll move, and then you call Graham and go, let's go 3803. And away you go. So in Australia, VKDMR is the primary network. It's got 55 repeaters worldwide, Australia-wide, sorry, and about 270 hotspots attached. It's currently undergoing some major changes. 2 years ago, they did a complete revamp of all the talk groups. Actually, 3 years ago, they went from one guy running it to a committee, which was much better. 2 years ago, they did a major revamp of all the talk groups. At the moment, though, they're wanting to do some more work. The software they're using as the master is a thing called IPSC2, written by a German guy who doesn't support it, won't answer calls. There are bugs everywhere. They don't have the source code to it. It's a complete nightmare. So Matt Perkins, VK2FLY, who's on the board of AR New South Wales and the Central Coast Amateur Radio Club, which is why he was in my head when I kept doing this, which is why the Amateur Radio Club's there, and top of the list actually. He's written his own master from scratch in Rust. And so he's currently testing it. So our Isaac's Ridge repeater is currently connected to that master, as are most VK2 repeaters. And my hotspot's connected there as well. And it's doing really well. So it's got much better information available, much better connectivity. And he's able to offer more things, like he'll be able to offer SMS between Motorola compatible devices using the Motorola compatible SMS or back-end data functions. One of the problems with DMR is there is no definition for the data side. It's a complete free-for-all, and every manufacturer has implemented it differently. So you might have an Anytone, and you might be talking to, I don't know, a Motorola or a Kenwood or something, and they won't be able to exchange data or SMSs because they use incompatible data formats behind the scenes. But I think the world seems to be standardizing on the Motorola format. Brandmeister supports the Motorola format, and I think IPSC3, which is what Matt's calling his rewrite at the moment, that's also supports the Motorola format. So some VKDMR talk groups, 505 TS2 is the call channel. It's like channel 11 on your CB. and it sounds like that sometimes. That's where everything happens. The vast majority of times you'll call on 505, you'll monitor 505, that's where it is. Tuesday nights is the one exception. Tuesday nights from about 7 o'clock or so, there's a national net run by Peter Forth, VK5 DMR. He's one of the guys on the council, the committee for VK DMR. He runs a weekly net on Tuesday nights. Just check in, say hello, and check your gear. It's a good time to check your gear out, just say hello, see some activity. That's actually on 505. There's another net on TG5. TG5 TS1 is for general nets and broadcasts. That's where the WIA broadcast appears. You want to hear, I don't know when it happens. You have to go search the net for it. But that's where the WIA broadcast happens and other bits and pieces, other people. If you want to run a net one night on DMR, you can put it on TG5, no one would mind. That's what it's there for. As I said before, 3801 to 3809 is the chat. TG9990 TS2 is the parrot. Parrot's interesting. That's how you check your radio and everything's working. So you bring that up, you program that in, you key up, you say a few sentences, you let go. It'll come back to you. Now, the new parrot actually comes back with your call sign and says, hello, blah, and then replays your audio back to you so you can hear what's going on. So you can tell if you're sounding... That's how I worked out that my standard microphone that comes with the Redivus is crap. Brandmeister is probably the biggest one. It's US based. Ignore the colours here. That's just locations of people that were talking when I took the snapshot. There's actually Brandmeister in most, it's all through North America, a bit down there. There's a few in Australia, lots in Europe and such, South Africa. Brandmeister has thousands of talk groups and it's quite a complex thing in itself. The hotspots have access systems where you can control which talk groups are statically bound and what are dynamically bound and what you're listening to and who you're connected to, and it's all a bit exorbitant. There are Brandmeister repeaters in Australia. We don't have one in Canberra. If you want to talk to the Brandmeister network, you'll do it in your hotspot. I think you're all starting to come to realise that if you're going to run digital radio, you need a hotspot. We'll talk about that in a minute too. So, no. There's a thing called an ESSID, an extended SSID, which goes on your hotspots, and that can be from 0 to 255 or something, or 0 to 99 actually. It's 2 characters. And it's really only useful if you have multiple hotspots. But when you set up the connection to the network, you also tell it what ESSID it's going to do, and it takes your DMR ID and adds the 2 characters to the end of it. So you can have multiple hotspots. You don't need another DMR ID. If you go to brandmeister.network, there's a dashboard there. There's information about how to use it, what to do. It's quite enormous. A lot of people don't like it because the admins have a reputation for not being the friendliest. But then again, they've got 25,000 hotspots and nearly 3,000 repeaters connected. So, and that was there was 27 repeaters were receiving, i.e. hearing and transmit, and 1,300 repeaters were keying that up. So it's a big network. Makes life fun. So the other significant networks, the original one was DMR Mark. That was the DMR Motorola Amateur Radio Club. And they initially set all this up so they could play with Motorola gear they'd stolen from work. They're still around. You'll see, I didn't put DMR Plus on there, but that doesn't matter. TGIF is another one, it's a slightly odd one. It's Europe-based again, or British-based. Some of these are British-based. System X/Freestar is British-based, but now global. And that's actually, the Freestar side of it is a cross-platform. So there's D-Star Freestar repeaters and DMR Freestar repeaters and P25 D-star, Freestar repeaters and such. And they all link in through XLX and transcoding and such. Quite an interesting system. And again, these are, once you get up, you'll need to have a hotspot to access all of those. FreeDMR is actually a nice thing. Now, one of the things that, and we've had some troubles with a local on this, VKDMR is configured and run like a professional network. The idea behind it is that not for you to experiment with, but for you to communicate with. So when you connect to VKDMR, it's got to be there, it's got to be reliable, it's not going to be fucked around with. However, FreeDMR is there for fucking. You want to screw around with DMR, do it on the FreeDMR network. And just search for it on the web, you'll find more information. Most hotspots have the ability, especially if you're using a WPSD hotspot, you can have profiles and you can connect between. I might mention that a bit later. The hotspot coverage is very minimal on this, actually, more than it should, less than it should have been. And there are more. There are actually too many different little individual networks. Some people, I know of people that are actually running their own master and have like 2 or 3 repeaters connected, just as like a separate, like an ARIS system, an emergency services system, or just for their town. They don't want the whole thing, they just want a repeater. They might have other repeaters set up. They just want their own little network. They run their own master and go for it. Plenty of people do that. You can too, just don't put it on our network. YSF. Now I'm going to, big disclaimer here, I know naff all about YSF. Everything I've learned has been through reading about it on air, or reading about it on the internet, or playing around with the DMR to YSF stuff and doing some support for it in WPSD. So YSF is Yaesu System Fusion. It's basically Yaesu's attempt to make their own proprietary version of D-Star, but keep it more proprietary. It uses C4FM as its underlying digital mode, and AMBI2 as its codec, which means you can interoperate with DMR and P25. It is proprietary. I believe some of the specs have been reverse engineered. It's certainly, the on-air protocol has been reverse engineered, and that's been, or it might even be publicly available. I know Jonathan supports YSF, receiving and transmitting YSF in hotspots in MMDVM host. It has 4 operating modes. There's a voice and data mode where there's a voice mode and a low bandwidth data mode underneath, about, I think it's 1.2 kilobits per second. There's a voice FR mode where it doubles the amount or increases the amount of data available for voice, giving you a higher quality voice. There's a data FR mode, which is the same thing but gives you higher data bandwidth, up to 9600 baud, I think. And finally, it'll do FM. And one of the big selling points is this auto feature where it automatically works out what you're trying to do or who you're talking to and converts it automatically. I don't know. I don't have a radio. They have their own proprietary network called YSX, and it is an absolute closed shop. You buy the gear or the software from Yaesu, or you use the Yaesu provided infrastructure, and never the twain shall meet. Except some people have reverse engineered parts of the protocol, and they now offer some FCS or YSX to XLX or similar interoperability, so you can connect to YSX, some YSX rooms from DMR using DMR to YSF or using XLX reflectors. Now, only the ones that are not running the Yaesu software but are running a third-party software hacked in will work, but there is some interoperability there. And again, it uses rooms, just reflectors, the same thing. I don't know how the addressing works. I could not find information on this. You might be able to tell me how the addressing unit works? No? No. I don't know. Who here has a YSF capable radio? I can probably find out in a minute. No one has one? Well, I'm going to move on then. P25, I know a bit more about P25 because I've used it at the RFS. P25, Project 25, or APCO 25, was originally developed in the US. for their public safety networks. It is very similar to DMR. It has a very similar sort of concept and reason for being to DMR. And NXDN and Tetra, actually, they're all about the same. It is, however, very much a commercial focus. I don't know of any ham radios that support P25 out of the box. I think there's a couple you can hack it into, but I think there are none that support it natively. It uses talk groups identical to the way DMR works, and in fact, a DMR trunking system and a P25 trunking system, you can't, from the user's point of view, you can't tell the difference. Although P25 does have some really nice back-end stuff like over-the-air programming and data transfers and out-of-band connects, and the Motorola radios actually have some really nice features, like you can have Starlink on the roof of your car, and if the link to the tower goes down, it'll back it up and you'll keep talking via Starlink. The RFS is installing that as we speak. So it means that even if fires take out your infrastructure, you've still got Starlink in the car to get back to Homebush. So there's very limited amateur infrastructure, but your MMDVM modem actually supports P25, so you can use your P25 stuff through MMDVM. I don't know on the amateur space exactly how much support there is or where you connect to. If you've got a P25 radio, then this is the sort of stuff you'll start studying yourself, but just be aware that a simple hotspot, well, not that one, but one of those, will do P25. So the original P25 was a 12.5 kilohertz C4FM with an IMB codec. That's actually an open source codec now, or not open source, out of patent. P25 phase 2, which pretty much they're all moving to because it gets you that, twice as much communications in the same bandwidth, is now basically functionally identical to DMR. It's 12.5 kilohertz TDMA2 slot with AMB 2 plus codec. You can actually listen to the PSN yourself if you've got an SDR dongle of some sort, an RTL SDR. There's a bit of software called SDR Trunk, which is Java. You download the Java runtime, you download the SDR Trunk, and then go to radio reference and get the control frequencies. And that's all you need, the control frequencies for, say, Stromlo or Isaacs or Mount Tenet is a good one, yeah. Yeah, I think there is one at Mount Ainslie. And any of those, and you can actually listen to the PSN, you can listen to the Fireys, you can listen to New South Wales ambulance, you can't listen to the ACT Fireys, the ACT ambulance, and about 2/3 of the buses, the other third aren't encrypted yet, but about 1/3 of the buses are unencrypted. And the ACT RFS is unencrypted, so is the SES. So you can listen to those if you want. I haven't done it for a while, but I used to. One tree. There's about a dozen sites around town now, and just out of town in New South Wales. Actually, the ACT is now piggybacking on the PSN. So originally there used to be what's called the GRN, which is the first iteration of this in New South Wales. And the ACT had a thing called the TRN, which was the same thing but here. And they actually had the same company doing it, Motorola, I believe. And they actually decided fairly early on in the piece to link the two. And so now the ACT TRN, even though they still call it TRN, is literally just the same as the PSN, but in the ACT. There's no difference. So if you take your ACT truck out to New South Wales, it'll work, depending on where you are, because they've got geofencing on some of the channels. Anyway. Right, so let's talk about M17. Now, M17 was developed originally by Wojciech Kaczmarski in Poland. It's called M17 because that was the address of the place they were at when they made it, when they designed it, which I think was like a warehouse or a pub or something, I'm not sure. They did actually tell me it was M17, thus, some long, weird Eastern European name, yeah. Website's the m17project.org. It's a free and open specification. Again, the M17 specification is just the protocol wrapper. Remember we talked about protocols? It's just a protocol wrapper. It uses codec 2, And I believe it's the 1600-bit variant in codec 2 as their audio codec. It's not currently supported in any commercial radios. There is Lin HT coming, which is supposedly a Linux-based handheld. That's actually a picture of it there. There is some hacked Retevis RT3Ss. Trouble with the RT3S and a few of the other, like the Anytones and similar, is that the DMR is done in a chip on board the actual radio. And so if you want to get the baseband out of the radio, you can't. You actually have to go into the radio and solder some wires to bypass the decoder chip inside the radio. Even though the radio doesn't decode ambi on the chip, it does some of the DMR stuff on there and doesn't pass enough of the baseband through the processor for them to do M17 properly. Too far. So there is some hardware. There's also an M17 module board, which is designed for like plugging into another radio. So you take a radio like your TM8110 or my FT857 was good enough for it, and you plug it in and it'll do M17 across, SSB or FM or something. I can't remember how I did it. I think it's over FM. It works. Now, about a year ago, up until about a year ago, Jonathan had support for M17 in all of his tools. So it was supported in PyStar and WPSD. And Jonathan had a lot to do with the guys, with Wojciech and a few of the guys all doing the M17 side. However, there was some doubts. Jonathan raised some doubts about the way the direction was heading. Jonathan's actually had 35 or 40 years experience in the digital radio field. He's worked with Tetris systems and P25 systems and DMR systems commercially in the UK and across Europe. So he knows his shit. His software is being used commercially in a number of places to do this stuff. So he expressed a number of reservations about the M17 protocol, and they just buffed him off. They also got a quite substantial grant from the US ARDC, and he was somewhat questioning where that money went. And it all came to a head, and he got the shits, and he pulled M17 support from all of his software. Bang, gone. Took it all out. So there's not an MMDVM host, there's no M17 gateway. It's all gone. Purged a lot. Third-party people kept it, and so they've forked his stuff, and so because a lot of his stuff actually runs behind the scenes, and I mentioned that later on the hotspots. So because Jonathan did that, and because us at WPSD and the PyStar people follow Jonathan's upstream software fairly closely, Chip and Andy pulled it from PyStar and WPSD respectively. So you won't find M17 support in the current distributions of either of those bits of software. If you want to do M17, you have to go to find the forked repos and do it all yourself. There was no animosity by the PyStar and WPSD people. It was simply because Jonathan pulled the support upstream and they can't support what's not available. And if they'd have kept supporting it, then they couldn't have taken any of the new stuff that's coming through from Jonathan. And there is some new stuff coming through, which I'll mention in a minute. So the last mode I'll look at tonight is FreeDV. Now, FreeDV originally started out as a graphic wrapper around codec 2 for HF. So there was a number of people involved. The current maintainer is Munir K6QV, and he looks after the system itself and some of the coding. So David Witten, and I couldn't find his call sign, David Rowe, VK5DGR. Now, David Rowe's the guy that created codec 2. Now, he didn't do it entirely alone. There's a lot of people helping him, but he's the major person and credited with doing it. And codec 2 is a major piece of work. Honestly, to get an ambi level quality free codec is just huge, amazing stuff. So yeah, Munir AQ, K6 AQ, there you go. So David has originally brought codec 2. Originally David Witten and David Rowe worked on this, and now it's been maintained by Munir. Munir is actually really active in the Discord, really easy to talk to. It implements digital voice over HF. That's why we're here. I said originally it used codec 2, but about 2 years ago, David started working on a variation, on a change, because codec 2 isn't really suitable for noisy environments. So based on some code, or based on some ideas from a couple of European Eastern Europeans anyway, he started working on RAID. Now RAID is a far more advanced audio codec that uses machine learning to look at the audio spectrum and identify the relevant bits that you can, the bits you can throw away, the bits you can keep, what you can compress. And so it gets a much better compression ratio. It also gets a much better noise resistance, because part of the training of the machine language model was feeding it noise and making it deal with it. So RAID v1 is currently where it is. The latest version of FreeDV 2.3.0, I think, was released only a month or so ago. It uses 1.5 kilohertz of RF bandwidth. It gives you 8 kilohertz of audio bandwidth, and it's really noise immune. It's essentially, if you can hear someone on SSB at all, you can have a RAID contact with them. It's really quite good. It uses a standard SSB radio. We follow the USA mandated restrictions of must use lower sideband for voice below 10 megs, because the USA class it as a voice mode, not a digital mode. And that trips a lot of people up. It certainly tripped me up when I was first trying to talk to people on 40 meters. I heard nothing. It's because I was in the wrong sideband. Just remember that. You can do it on 6 meters, you can do it on 2 meters. It's optimized for HF, but it works on the rest. So he's done a lot of good work. It uses cat control via ham live, so it controls your radio. It's got an inbuilt reporter, so you actually see what's going on. People come up red when they're transmitting. They come up green or yellow when they're actually actively receiving someone who's transmitting, so you can sort of see where the conversations are. This was only on 20, and that was the number of people. Most of them were Americans, but there's a few others in there. It works quite well. RAID's definitely something if you're a HF digital person, you like FT8 and that sort of stuff. If you've got FT8 running or JS8 call or any of the FL Digi modes, then you don't have to change your radio at all. This just plugs straight in. Okay, that concludes the modes part. Let's have a quick look at Quark repeaters. We have 2 digital repeaters in the ACT, one D-Star, one DMR. Those of you with D-Star or DMR radios have almost certainly already had a go at them. D-Star radio changed from it recently. It's on a minus 1.6 megahertz offset. And that was done so we could bring the VHF repeater on Isaacs back into service, the voice one, because it was being nailed by, and so was the D-Star repeater as well, was being nailed by some co-site interference, some adjacent site interference. And so there was a site just down the road that was causing us some interference, only on 600 kilohertz pairs. So as soon as we went to a 1.6 megahertz offset, the interference dropped away, which is why it's there at the moment. As we say here, it's VCO and RBM C, because C is for VHF, G is for the gateway, and CQ, and DMR 438 8125. It's on the new minus 7 megahertz offset, and it's hooked to the VKDMR network. So if you go to vkdmr.net, everything that's on there is valid for that particular repeater. Anything else you want to do? You need a hotspot. So stuff I haven't covered, and I won't cover, but I will quickly mention. DPMR is yet another standard, so many to choose from. It's designed basically it's like your old analog repeater systems, but just digital. It uses AMBI2 Plus and C4FM, and there's absolutely nothing to recommend it, but you may notice the term around it. It's got nothing to do with DMR and nothing that in the ham world supports it. It's strictly a commercial system. Tetra is very big in Europe. It was in Europe what P25 is to Australia and the US. There are some people playing with Tetra in the UK. I don't know of any radios or any systems in Australia with Tetra. So Tetra is, again, everything that I've said about DMR and P25 basically applies to Tetra. It's functionally equivalent. NXDN is a bit like DPMR. You may see it in the context of the ham radio. Oh, it's another ham radio system. It's not. It was another system built in the US for their public safety stuff and for public use. There's no use of it in Australia and no amateur radio gear available for it. I see people keep referring to NXDN as a ham radio thing. It is a ham radio thing in the US where second-hand radios are available, not here. And I will mention All-Star Link and Hoyt. All-Star Link is like I should have mentioned IRLP and Echolink on there as well. They're all the same thing, but they're over the air, they're analog voice. And then they use like GSM codecs or ULO codecs or similar to talk across standard telephone lines using IAX trunks and all the good VoIP. If you've ever done any VoIP work or ever been managed to Cisco PABX or anything, you'll know all the buzzwords and that won't seem familiar. And HOIP is literally a ham radio PABX. It's All-Star and telephones on your desk talking across the internet. There's not a lot of radio involved, but the two are interoperable, so you can, from a HOIP phone, dial an All-Star node and have a chat to someone on the air, which is interesting. Graham got me into HOIP recently. I had a couple of old VoIP phones sitting in the corner, so I fired one up, made it work. And now he calls me at odd times to complain about his All-Star system. Let's have a quick talk about hotspots. We all know what a hotspot is. I mention it so often tonight. So basically, what a hotspot is, it's a low-power computer, almost always a Raspberry Pi, but there are variations, connected to a board that has a radio transmitter on it and a small low-power CPU to do firmware type dealing with the radio and PTT handling and communications. The software that runs on the little board, the add-on board, the MMDVM board, is called MMDVM, which is, right? The software on the Linux computer or your desktop, if you're running it that way, which talks to the board, is called MMDVM host. So they do the communications, they do all the decoding and encoding of the protocols. And then the connecting out to the wider world is done by what's called the gateways. So the DMR gateway connects out to the DMR networks. YSF gateway connects out to YSF networks. IRC DDB gateway connects out to the D-Star networks, and so on and so forth. It does not encode or decode the digital. Remember this separation I've said between the protocol and the codecs? Well, MMDVM boards deal with the protocol. They deal with receiving it, transmitting it, converting it to some extent, and flinging it away. They do not touch the codec itself. That's just a payload in the middle. In all cases, it's just rewrapped and sent on its way. And of course, there may be simplex and duplex. That's a little idea of how they work. Your radio talks to the hotspot, hotspot talks to the internet. The way the world works these days. So there's the board. That's actually that board I've got there. Little duplex. There's one ceramic antenna. There's the other ceramic antenna. And that's a little display, an OLED display on it, so you can get some information. They use an ADF 7021 narrowband transceiver. It's about 20 milliwatts of output max. Maybe that, it may be not. You can actually adjust that inside the software. But most of them are running between 10 and 20 milliwatts of power. None of this is high precision, space going gear. It's literally how you get it. And the boards, most of them running on Raspberry Pis. Some of the bigger ones might be running on a 3B+. For instance, the MMDVM modem on our DMR repeater on ISACs, and in fact the IRLP repeater as well that I just rebuilt the other day, are both running 3B pluses with a repeater builder's board, which I have a photo of later. So they're Linux based, most of them using Debian based, so either Raspberry Pi OS or similar. And WPSD or Pi-Star is the software. Both WPSD and Pi-Star are built upon the G4 KLX software that Jonathan built. It's probably worthwhile talking about these. WPSD and Pi-Star are two competing hotspot. They're not really competing. They're sort of, they just exist. You can choose one or the other. If you have an older hotspot with a Pi 0 W on it, the low power one, the one that's now 12, 13 years old, you'd probably use Pi-Star. That's Pi-Star there. That's actually our DMR repeater. That's the interface to that I can see. It's using Pi-Star, mainly because I haven't changed it over to WPSD yet. WPSD wasn't around when we installed the thing originally. It works fine. It's using the same backend. So the backend is still using the same MMDVM host, DMR gateway, so on and so forth, that WPSD is using. WPSD, however, requires much more grunt. It's a much more featured front end. Functionally, they both do the same. Functionally, you can use either as you like, but WPSD just does a bit more. It has different profiles, so you can, you want to talk to TGIF or Brandmeister, then you can just select a profile and change your entire setup, and it'll reconfigure for whatever you got set up. And then if you want to go back to your previous profile and talk to VKDMR, you can just change your profile and it'll reconfigure the whole thing. It's got themes and more information. And for a repeater side, it has an API that we can use to generate a web page for people to see what's going on. But that's the hotspot. There are plenty of them around. That's the repeater builder's board. So that's what we're running in the DMR repeater on ISACs. But I have to kick the power to once a month or so for some reason. That's just you see a lot of those around. There's a bazillion of these on AliExpress. I honestly wouldn't, if you're looking for a hotspot now, I honestly wouldn't buy one of those because they're almost all of them still being shipped with Pi 0Ws. And they're old and slow and they're obsolete. And you're never going to get very far. You can't upgrade them to the latest Trixie. WPSD doesn't support them at all. And I'm not sure, I think Pi-Star still does. But again, Pi-Star's not quite as heavy on a system as WPSD, but it does a lot less. But still, it's worth getting something a little newer. BI7JTA actually produces really good boards. He produced that board, which is what I've got, that I showed you there. That's the duplex board. You don't really need duplex. Simplex is fine. For just one person using it at home, a simplex board is fine. So you can actually see the screen on this? You can actually get a larger display on your hotspot. That tells you a lot more information. As you can see, it says DMR up there. That gives you some information, but it's not something you're going to read across the room. That's just that little OLED screen there. You can actually get a 4-inch screen. And if you're the sort of person that likes having status displays and you've got a ham clock in the corner, then one of those will be your best bet. The BI7JTA is the one I would recommend, but there are plenty of others. Zoom Radio, DB Mega, Bridgecom, they all do decent gear and they're all quite supported. I only listed the ones that are supported by WPSD these days because there's no point in sending you off. This thing here was a cheap Chinese one that I first bought. Actually, I bought this before a DMR radio because I mistakenly thought these would let me decode DMR, and then I realized after I bought it that they couldn't. I had to go buy a radio. Such things happen. But I've upgraded that with a Pi 02W, so it now runs WPSD. When I haven't stolen the SD card to put in the IRLP node. Now, repeater builders are these guys here, and they really are doing these just for repeaters. Repeater builders is actually a complete repeater building site with like 12,000 pages of documents and shit for different radios, all for building your repeater and making it all work. Documentation on your TV8100s and anything your Motorola repeaters, your Quantars, whatever. Some of the guys involved in that have built this. This is a Pi 3B. with their own board on top, with a DB9 here, which connects off to the data in your radio, and that's what we're using for our DMR repeater. OpenSpot are their own thing. They actually do all this. They have an interesting little device called an OpenSpot Pro, I think is the only one they sell now, which actually has the transcoding chips built into it. So you can actually set it up and listen to a channel and have it connect up to the internet. And then actually it'll listen to the channel by itself and you'd actually hear the audio. It's the only one that currently does. Right, we're getting there. Almost done. The future. Right, so a couple of things happening. In your hotspot software, Jonathan is moving everything to MQTT. Currently, everything's written to log files, and then all the software parses the log files. That leads to delays, things being missed, and churn on the software. Even though we're using memory map file systems and shit now, it's still a bit awful. Plus, it means it's really hard to get information back into. If you want to control these softwares, you got to write. He wrote some control stuff where you poke text at a port to control things, which is all behind the scenes. You don't need to know about it, but those of us that fiddle at this level, nice. This will be great. He's already done the software. That's actually out and available. I haven't heard whether the chip's working on his side yet. Another bit of software at the moment that is there, but and has some custom hardware coming for it, is a thing called MMDVM cross mode. Now, basically, it's MMDVM host, but it supports the DVSI chips. And he's getting some custom hardware made, which is you'll be able to do live transcripts. So if you're a DMR radio, you'll be able to drop into a D-Star network, just straight in. And the MMDVM cross mode software will be the bit that allows that does the protocol conversions, and then it'll drop the codec down to the DVSI chips to turn it into whatever the relevant codec is for the protocol going out. That software's already there. It's been there for 12 months, actually. He's just waiting on the hardware to make that work. I'm not sure if we'll put that in WPSD at this point. I haven't heard any mentioning about that. This one is really interesting that he announced literally a week ago. A board called the SX Siva. It uses the Semtech SX1255 based SDR transceiver. So it's a full SDR transceiver. It supports VHF and UHF. And what he's done is he's taken the MMDVM software, which would normally talk to MMDVM host. It would normally talk to the radio chips, and he's converted that to also talk IQ via SOPI SDR to SDR receivers. So you can use any SDR receiver that SOPI SDR supports as a hotspot. So this will be a new MMDVM board, like that goes on top, which supports an IQ radio, which will let them do everything, including FM, from your hotspot. Although it'll probably need a Pi 4. It'll need more. Everything needs more power. Just ask the AI dudes. So at the moment, I know they've got some Lime SDRs working with it. He does his development using the Semtech SX Siva, which I think the M7N guys are also playing around with. So that's coming. So I don't expect to see much of that in the next 12 months or so. Those of us that see the back end stuff, and those that are on the open DV mailing list and a few others will see it. But interesting things are coming that, more protocols, all the better. Right, this is the last section, guys. So the last bit, there are bits in this entire ecosystem which aren't radio bits. So you can actually talk D-Star using DroidStar, particularly if you have what's called a thumb DV or similar. I actually bought an Ambi server, which is a DVSI chip in a small board that sits on the Ethernet, and I can talk to it via the radio, talk to it via the Ethernet from a number of systems, and use it to convert between normal voice speech or into D-Star, into Ambi or Ambi 2 Plus or whatever. Thumb DV, it's like the Thumb DV is the same thing, but it's a USB that plugs in and looks like a serial port, provides a chip on the outside. DroidStar will make use of those. Actually, DroidStar does have an inbuilt IMBE or Ambi encoder decoder. It's not very good, but it's enough to make it work. So you can use these without having a thumb DV or similar. But that'll get you onto D-Star anyway. You can then connect to, say, VICO and RBM-G and then talk out to the local, and works well. Peanut is an interesting sort of whole second niche sitting over here. It's written by one guy. He's done an amazing job. It's a whole separate ecosystem. But what it does do is he connects into XLX reflectors, or he can do. So if you've got an XLX reflector, you can get a Blue DV or a Peanut connection in, and then you can use Peanut to connect to some XLX reflectors and chat backwards and forwards, but only those that do transcoding. Interesting stuff. You don't need to buy anything. You just need a phone or a computer or something and download the software. And the last thing that Mike is going to show you is a mic. These are OpenSpot. This is the OpenSpot. That's this thing here. It's basically a little Wi-Fi device, but it has a DVSI chip built in, and so it can talk all the DMR, D-Star protocols built in. I've never played with one, and I look forward to having a go after this. They're not cheap, but they're not hugely expensive either, and you can literally just wander around the house with this on the Wi-Fi and connect it to or mobile hotspot, although, yeah, that can cause its issues. Or wander around with that, and that'll give you access over the network. So it's not an RF device insofar as it doesn't use a handbands, but it does, even though it's called Shark RF, but it's not. It does use Wi-Fi. So you can use that to connect as well. That's an interesting device. Right. I'm sure you're all as glad of this as I am.